Okay, welcome. This is the algebra video. I am so excited you've gotten this far in our lessons. I really hope that you're getting a lot of great benefits out of the videos. So today what I want to go over with you are the rules for algebra. So we're going to start with the really basic stuff. We're going to understand how to work with variables, adding, subtracting, just the basic stuff, and then we'll go from there, okay? We're going to build on that. So first things first, rules for adding and subtracting variables. So variables are basically, we know the most common one to be x. And x represents something that is unknown. We don't know what is the number yet, so we're just using x as a placeholder. Now x can behave in a couple different ways. When we're adding x, we can do x plus x equals 2x. Okay? We can also do x plus 2x equals 3x. The important thing is that when we're adding x's, the number in the front is what we add. And when there's no number, we have an invisible 1. Okay? Now, what if it has an exponent? An exponent is this small number up here. This means x times x. Okay? Now, what if we have x squared plus x? What does that equal? Well, that equals x squared plus x. We cannot add these together. And the reason we can't add them together is because they don't have the same exponent. So here we have an exponent of 2, but in this one, there is no exponent. That means there's an invisible 1. If they do not have the same exponent, we cannot add them together. So if we were to have something like, let's say, x squared plus x plus x, there are no other x's with a square. So we can't add it to anything. So that's just going to stay as x squared. But here we do have an x and an x that have an exponent of 1. So we can add them and we get 2x. Okay? So let's do a couple of practice problems. Let's make it a little more complicated. And just to make sure, if we have x squared plus 2x minus x, I want to make sure that you understand that once again there's no other x squared, so it stays the same. But this is 2 minus 1. This becomes plus x. Okay? So now that we understand that the rules are the same for adding and subtracting, let's go ahead and get into some practice. So I'm going to zoom this in here so we can focus on just one problem at a time. So here we have an x squared and we have a plus 5x squared. Super important. The sign in the front is the sign that belongs to that number. Okay? So this is 1 plus 5. There are no other x squareds, so we're going to do 6x squared. Okay? Then we have plus 3x minus 2. So this is 3 minus 2. 3 minus 2 is 1, so it's plus x. Because remember, with the variables, the 1's are invisible. Okay? We have no other x with a variable, with an exponent of 1. So let's do now our last number. There are no other numbers to add or subtract to it, so it's just going to be minus 8. So essentially, we're grouping together everything that is the same. And this is called combining like terms. Okay? We're combining like terms. So, we're going to do one more together and then I want to give you a chance to try it out. So, we have 3x squared plus x squared. There are no other x squareds, So we're just going to do 3 plus 1, that is 4x squared. Then we have 6 minus 8. These are the only ones that have x's with an exponent of 1. So I'm just going to put these two together, and 6 minus 8 is negative 2. So this is negative 2x. I hope you reviewed positive and negative numbers. If this confused you here, 6 minus 8 is negative 2, pause, go back, look at positive and negative numbers, and then come back, okay? And then here we have negative 9 and negative 14. Negative 9 minus 14 is negative 23. Okay? All right. So now that we did that one together, I want you to give this one a try. I'm going to give you a little bit. If you need extra time, don't be afraid to pause the video and take the time you need to figure it out. And then I'll come back and explain it. Okay, so now that you got a chance to work that out, let's take a look on how to solve it. So we're looking for the ones that have the square. So a squared and a squared. So that has a plus in front of it. So this is 1 plus 3. That's 4a squared. So far, so good. Then we have, now we're going to look for the ones with an exponent of 1. So 5a, negative 12a, negative 8a. So 5 minus 12 is negative 7. And we still have to minus 8a. Negative 7 minus 8a is negative 15a. Now that we've done that, what's left is our negative 2. There are no other numbers, so we just leave that just like that. Okay? Hope you got it. Oh, excuse me. I hope you got that. Let me know if you have any questions. You can submit them below in the questions, okay? We got one more. I want you to give this one a try. I'm going to give you a little bit of time also, and then I'll go over it with you. Okay, so I hope you got it. Let me go ahead and show you how to do it. So this one has an n to the third, another n to the third. So this is 1 minus 12. That gives me negative 11 n to the third. Then we have, let's look for the next number, 3n squared minus 8n squared. So 3 minus 8 is negative 5n squared. And then we have 3n minus 2n, and 3 minus 2 is 1, so plus n. Okay, hope you got it. Feel free again to pause and review them again. If not, we're going to move on to rules for multiplying. So when we're multiplying, what we do is we add the exponents. So here this is x to the 1, x to the 1. They're being multiplied together, so I add the exponents and it becomes x squared. In the same way, x squared times x, this is a 2 and a 1. This becomes x to the third. Okay? If we have x squared y times xy, we add up the exponents for each variable. So we start with the x. 2 plus 1 is 3. And then we do y. 1 plus 1 is 2. Now, each variable carries its own exponent, so we don't add up the exponents for two different variables, okay? Let's just do one more example. A squared b times abc. We start with a, 2 plus 1, 3, 1 plus 1, 2, and c just has the 1, no other one, so C. Okay, I hope you got that. Let's look at an example together. Now this one has a number. We're going to multiply that number first. There is a 1 here. Remember, those ones are invisible, so it just stays at 2. Here we have m next, m5 and 4. So this becomes m to the 9th power. And there's only one n, so it stays like that. I hope that made sense. Go ahead and give this one a try, and then I'll come back and I'll explain it. Okay, so here we go. 3 times 5, 15. M, we got a 5 and we got a 1, so it's 6. And then N, we got a 2 and we got a 3, so it's 5. There you go. Hope you got it. If not, here is one more. Actually, we have 2 more, but work on this one first. I'll give you a little bit of time. Okay, I hope you got it. If not, don't worry. I'm gonna go over it now with you. So let's multiply the numbers first. 6 times 3, 18. Then we have A, 4 and 2, that's 6. And B, 1 and 2, that's 3. Some people might multiply these two by accident. That's okay. Remember, what we're doing is we're adding them. Okay? We got one more practice, and then I'm going to show you a different kind of multiplication. Go ahead. Okay, I hope you got it. Let's go ahead and go over it together. So this is a 1 and a 3, so that's 3. Then we have A, that's a 2 and a 5, so it's going to be to the 7th power. We have B, 1 and 2, that's 3. And then we have a C, just one C, so we're going to leave that one just like that. So next one I want to show you is something called distribution. This is a way of multiplying also. But with distribution, what we're doing is we have parentheses, just like these, and what's on the outside gets multiplied to each thing that's on the inside. So for example, 3 times x is 3x, and 3 times 4 is positive 12. That's it. That's how you do this one. Okay? So another example, if we were to have 3 times x minus 6, for example, it would be 3 times x is 3x. 3 times negative 6, negative 18. Okay? Now that I've done that for you, I want you to give this one a try. I'll give you some time. All right, here we go. So we're doing 2x times x. Remember 2x times x, we add the exponent. So that becomes 2x squared. And 2x times negative 6, 2 times negative 6 is negative 12. And the x stays the same. So this becomes minus 12x. Okay? Let me see. We got one more, and then we're going to go over division. I'll give you a little bit of time to figure this one out, okay? Go for it. Okay, so let's multiply these together. I hope you got it right. If not, don't worry. I'm going to go over it with you right now. We have 2a squared times a squared. So 2 times 1 is 2. A squared is a to the 4th. Now, plus, because that's a plus. 2 a squared times a to the 3rd. 2a to the 4th plus 2a to the 3rd. I hope that made sense. Please submit a question to us if you're not sure about something. I will be more than happy to provide you an answer. Next thing we're going to talk about is rules for dividing variables. Okay? So here we go. When we divide variables, it looks something like this. Okay? When we divide variables, what we're doing is we're subtracting the exponents. So it's the opposite of what we did with multiplication. So here, the only variable on the bottom is a, and it has an exponent of 1. So we do 2 minus 1 is 1. Because it's positive, it stays on the top. If the answer is negative, we move it down to the bottom. But here it's positive, so it stays on the top, and the b stays the same. Okay? Another example is, let's make it a little more complicated. Here we have a to the 4th minus the 2 from the bottom. So it's a squared, because 4 minus 2 is 2. Here, b, this has an exponent of 1. This is 3 minus 1, so it's also 2. Nothing is negative, so nothing goes on the bottom. What if we do have something that is negative? What does that look like? Let me explain. I will show you. Okay? What if we have something like this, where 1 minus 2 gives you negative 1? We put the a to the 1 power on the bottom because it's a negative, and the b stays on top. One more time. Let's say we have xy squared over x squared y. 1 minus 2 is negative 1 for the x. And 2 minus 1 is positive 1 for the y. Because it's negative 1, the x goes on the bottom. Because it's positive 1, the y goes on the top. Okay? So let's look at an example together. Go ahead and try it out. Actually, no, I'm going to explain this one to you because this one's a little bit different. So we're going to do here 2 minus 1 is 1, and it's a positive 1, so it's going to stay on top. And b, 1 minus 1 is 0, which means it cancels out. And all we're left with is a. Okay? So that one's a little bit different. I want you to go ahead and give this one a try. I'll give you a couple of seconds. Pause the video if you need to, if you need a little more time to figure it out, and go back and look at the notes, okay? And I'll come back in just a bit to explain it to you. Good luck. Okay, here we go. So here we have a number on the top. There's nothing to divide it on the bottom, so it stays the same. A to the 4th and a to the 1 on the bottom. So 4 minus 1 is positive 3. And for b, we have 1 minus 3, which is negative 2, which means it's going to go on the bottom, b squared. When we put it on the bottom, when we put it on the bottom, we don't put a negative, we just put it on the bottom, okay? Just in case that's a question you had. Okay, I hope you got it. If not, don't worry. Here's another one for you to try out. I'll give you a couple of seconds to do it, and then I'll go over it with you. Okay, so let's work this one out together. Here we have 12 divided by 4. With numbers, we divide them regular. 12 divided by 4 is 3, so that one goes on top. 5 minus 1 is 4, positive 4, so it goes on the top. And then we have 1 minus 3, which is negative 2, so it goes on the bottom. So 3a to the 4th over b squared. But the next thing I want to go over with you is solving for an unknown. So solving for an unknown is usually questions that look like this, okay? How do we solve questions that look like that? Well, essentially what you want to do is you want to get the x by itself on one side of the equal sign. Think of it as your ultimate goal. Your ultimate goal is to get x by itself on one side of the equal sign. So if we have x plus 1 equals 2, the x is not by itself because it has a 1 by it. So how do we get rid of the 1? We get rid of the 1 by doing the opposite operation. So here this is a plus, the opposite would be minus 1. And when I minus 1, I have to do it on both sides of the equal sign. Whatever I do to one side of the equal sign, I must do to the other. So when I do that, I cancel this out, and I'm left with x by itself on this side of the equal sign. I bring down my equal sign, and then I do 2 minus 1, which is 1. Okay? Let's do one more example. So we have x minus 3 equals 5. How do I get x by itself? Well, it has a 3, and it's minus, so I have to do the opposite. So I'm going to do plus 3, plus 3. That cancels out. Now I'm left with only x on this side. I bring down my equal sign, and 5 plus 3 is 8. So x equals 8. You know what? There's a couple other ones I want to go over with you. So let's say I have 3x equals 12. Here, the x is not alone because the 3 is multiplied to the x. So how do I get the x alone? I divide, because that's the opposite of multiplication. And whatever I do to one side of the equal sign, I do to the other side of the equal sign. So I cancel this out, and x equals 12 divided by 3, 4. Let's say I have x over 3 equals 2. Here, the x is not by itself. Once again, it is being divided by 3. So I do the opposite. What's the opposite of division? Multiplication. So I multiply by 3. I do the same thing to the other side, because whatever I do to one side of the equal sign, I must also do to the other. So when I multiply, I cancel that out, and I'm left with the x here by itself. And 2 times 3 is 6. Let's look at another example together. Actually, you know what? Give this one a try. I've gone over a couple examples. I want you to give this one a try. I'm going to give you a couple of seconds, and then I'll go over it with you. Okay, I hope you got it. If not, don't worry, I'm going to explain it to you now. So I'm going to do minus 4 because I want to get the x by itself, and that 4 is added to the x. I'm going to do the opposite, so I'm going to subtract 4. And I'm also going to subtract 4 from this side. So x equals 10 minus 4 is 6. X equals 6. Awesome. Now that we got that one, why don't you give this one a try? This one is 2 steps. I want you to try and do what you think you need to do, and then I'll go over it with you. Okay, I hope you got it. If not, no worries. First thing we're going to do is we're going to get rid of what's furthest away from the x. So this 2 is real close. So let's work on the 3 first. So we're going to do minus 3 minus 3. 2x equals 12. Okay? Then, remember our goal is to get the x by itself. we can't yet because we need to divide it by 2. This cancels out and it becomes x equals 6. Okay? So, now that I've done that, I want you to give this one a try. It's a little more complicated, but remember, the goal is to move things around so that the x is by itself on one side of the equal sign. Go ahead. Okay, I hope you got it. First thing I want to do is I'm going to minus the x here. And I'm going to do it from both sides. The reason I want to do that is because I don't like that the x is on both sides of the equal sign. Now I've canceled it out, and now I only have it on one side of the equal sign. So 2x minus x, or 2 minus 1, is x. So now I bring everything else down, the plus 4 and the negative 11. Okay? Remember, the sign in front belongs to that number. Now I'm going to minus 4, and I'm going to minus 4. This cancels out. Negative 11 minus 4 is negative 15. Okay? All right, I hope you got it. Here we got another one. If you notice, this one has the distribution. We went over that already. I hope you still remember how to do it. So give it a try, and then I'll come back and I'll show you. Okay, I hope you got it. If not, no worries. I'm going to explain it now. So what we do first is we distribute that 3, right? So 3 times x is 3x. 3 times negative 8 is negative 24. Bring down everything else. Then I'm going to minus 2x because I want everything on one side of the equal sign. So 3 minus 2 is 1, and remember 1s are invisible. X minus 24 equals negative 1. Now I still want the x by itself. I have a 24 subtracted from it. Now we're going to do plus 24 plus 24. So x equals 23. I hope you got it. Okay, I'm going to take a pause here. We just went over some of the basics in algebra. In the next half of this video, I really want to go over with you some of the more complicated types of algebra problems you could come across. This is a good time to take a break, take a breather, and come back and keep going, okay? Let's do it. Hey, welcome back. So in this lesson, we're going to talk about the next level of algebra. So we started off in the last lesson with easier concepts like the basic stuff, and now I want to show you more challenging concepts that will help you prepare for those more challenging questions in the mathematics knowledge section, okay? So the first thing we want to start off with is solving for two unknowns. So we looked at solving for one unknown, and the goal with one unknown was simply to get the variable, the unknown, the x, whatever it is, by itself on one side of the equal sign. So when we're solving for two unknowns, usually we will have two equations. So we want to basically isolate one of them, or basically get rid of one of them, okay? So that we can just solve for the first unknown and use that information to solve for the second unknown. So it's going to sound a little weird, me just explaining it like that. So let's go ahead and look at an example. So in this first one, what we can do is two approaches. We have substitution, okay? And we also have combining. When we combine them, okay, when we combine the two equations, what we can do is we can kind of manipulate one of them so that if I combine it either by adding or subtracting it, then essentially one of the variables will cancel out. So what does that look like? Okay, first of all, I want to look to see if there's anything I can cancel out. Like if I add 2x plus x, will that cancel out? No, that gives me 3x. If I subtract 2x minus x, will that cancel out? No, that just gives me x. If I add y plus y, will that cancel out? No, that gives me 2y. But if I subtract and I say y minus y, will that cancel out? Yes, it actually does. Okay, so let me do that then. I'm going to multiply the second equation, the entire thing, by -1, okay? And I'm going to rewrite it. So this becomes negative x minus y equals -4. So now that I've done that, I'm going to cross this out, okay? And now I'm going to combine these two equations. And I'm just going to like add them or, do an operation. So I start with 2x. 2x minus x gives me x, because 2 minus 1 is 1. Y minus y gives me 0, so that just cancels out. Equal sign is carried down. 5 minus 4 is 1. X equals 1. So by eliminating, okay, or combining, it could also be called elimination. By eliminating or combining, I got rid of one of the variables, and now I have one variable left, and it just tells me that x equals 1. Okay, so now I know that x is 1. I still have my two original equations, and I still want to know what y is, okay? So that means I have to solve for y. So I'm going to use the second equation, x plus y equals 4. Okay, remember this one right here before I transformed it? So now that I have x, I'm going to replace it right here. I'm going to substitute it. So wherever I see an x, I'm going to substitute it with 1 because I now know what x is. So 1 plus y equals 4. I subtract because I want to get the y by itself on one side of the equal sign, and that 1 is added to the y, so I'm going to subtract. And whatever I do to one side of the equal sign, I also have to do to the other. This cancels out, and I'm left with y by itself on this side, and 4 minus 1 is 3. So x equals 1, y equals 3. And that's it. That's my answer. Okay? So we do this with the process of elimination or combining. So let's go ahead and try something that's a little more difficult. So here we see x and 3x, negative 3y, negative 4y. So neither one of these, I can't do x minus 3x. That's not going to cancel out. I can't do 3y minus 4y. That won't work, okay? But what I can do is if I multiply this x by negative 3, this would become a negative 3x. And this will be a 3x. And negative 3x plus 3x is 0. So that means that what I want to do is I want to multiply the whole first equation by negative 3. So for me, this reminds me a lot of when we're adding and subtracting with fractions, and we have to multiply stuff to be able to get the same denominator. It's kind of the same idea. We're just trying to figure out, what do I multiply one of these by to be able to like eliminate things and then be able to solve. Okay, so now that I did this, I end up with I distribute everything. Negative 3 times x is negative 3x. Negative 3 times negative 3y is positive 9y. And negative 3 times negative 2 is positive 6. And then I'm going to rewrite the second equation underneath this so that it's just easy for me to see this. So now, negative 3x plus 3x cancels out. That just gives me 0. Okay? And 9y minus 4y is 5y, because 9 minus 4 is positive 5. And here, 6 plus 4 is 10. Okay? Essentially what we're doing is it's like we're adding. And when we add, if this is a negative, it remains negative. Like it's still 9 minus 4. Okay? And then if it's positive, it's 6 plus 4. So we're using the sign that's in front of the number. Positive 3x, negative 4y, positive 4. All right, so now that I have 5y equals 10, that 5 is multiplied to the y, so I'm going to divide by 5 to solve for y, to get it by itself, and I get y equals 2. Okay, now that I've solved for y, I go back to my original equation. And I'm going to use the first one. X minus 3y equals negative 2. But now I know what y is, so I'm going to substitute. Wherever I see a y, I'm going to replace it with 2. So I'm going to rewrite this. X minus 3y, but that's actually times 2, equals negative 2. You see how I replace the y with a 2? Okay, so now I'm going to multiply. X minus 6 equals negative 2. I got that because negative 3 times 2 is negative 6. And this this 6 is being subtracted from the x. So to get rid of it, I'm going to add 6. I'm doing the opposite. X equals negative 2 plus 6 is positive 4. So y equals 2, x equals positive 4. Okay? All right, so now let's take a look at another concept. So when we have something like x squared plus 3x plus 5, for example, this is called a quadratic equation. It's called a quadratic equation because there's an x to the square to the second power, okay? If it was y squared plus 3y plus 5, it would still be a quadratic equation. What makes it quadratic is this variable right here, okay? Now, we get to this quadratic equation by doing something called foiling. And foiling is when we multiply this right here, okay? And FOIL actually stands for the process or the order in which we multiply. So it stands for first, outer, inner, and last. Okay? So if we were to do, before we do this one, let's do just kind of like a random example. Let's say we're doing x plus 1, x plus 6. Okay? We do the first times the first. X times x is x squared. We do the outer. X times 6. Positive 6, so it's positive 6x. Now we do the inner. Positive 1 times x is positive x. And now the last, positive 1 times positive 6. 1 times 6 is just 6. So now that I've done that, I'm going to look at this and say, well, are there like terms? Can I combine anything? Remember in our last lesson, combining like terms? This is where we use it. Plus 6x plus x, 6 plus 1 is 7. So this becomes x squared plus 7x plus 6. And that's my answer. So this is the process of foiling, okay? So now that we've done that, let's look at this example over here. X plus 3 times x plus 4. So we do the first, x times x, x squared. We do the outer, x times positive 4, positive 4x. We do inner, positive 3 times x, positive 3x. And we do last, positive 3 times positive 4 is positive 12. We combine like terms, so we add up these two, and we get x squared plus 7x plus 12. And there we go. Okay, so let's look at some practice. Yeah, let's start with this one. Okay, I'm going to go ahead and give you a chance to try this one. Even if you get it wrong, that's okay. I still want you to give it a try. So if you want, pause the video at this moment, and when you're ready, just hit play and I'll go over it with you. Okay? All right, here we go. So remember, it's FOIL. I'm going to write it here so we can remember. First times the first, 3x times x is 3x squared. Outer times the outer, 3x times 1 is just positive 3x. Inner times inner, positive 2 times x is positive 2x. And last, positive 2 times positive 1, positive 2. So now we combine these two, we add them up. They have the same variable, the same exponent, so we can add them together. So we get 3x squared. 3x plus 2x is 5x plus 2. And there we go. Okay, let's look at the next example. So here we're already working with a -5 or -5. So make sure you pay attention to that as you're foiling this out. So if you want to give this a try, go ahead and hit pause on the video and give it a try. And when you've already given it a try and you're ready to look over it, come back, just hit play, and you'll see the explanation. Okay, here we go. So first one, x times x is x squared. Outer, x times positive 1 is positive x. Inner, -5 times x is -5x. And last, -5 times positive 1 is -5. So now we combine these like terms. 1 minus 5 gives me -4. So that's -4x minus 5. Something very important that confuses people, just because there's a negative behind this x does not mean that negative belongs to x. The sign in front of a number or in front of a variable is the one that belongs to it. So if there's nothing in front of this x, that means it's a positive x, okay? And this negative belongs to the 5. So I hope that that distinction helps. Okay, so here, let's try another one. This gets a little more difficult. I'm going to give you a hint. You're going to FOIL these two first, and then after you FOIL it, you go ahead and multiply the whole thing by 2. But don't forget to multiply by 2 because that's where people make a mistake, okay? So if you want, go ahead and hit pause now. Give this a try, and when you're ready, come back to watch the explanation. Okay, here we go. So let's get started. First times first, 2x times x is 2x squared. Outer, 2x times -7 is -14x. Inner, positive 1 times x is positive x. And last, positive 1 times -7 is -7. So I'm still going to put this whole thing in parentheses and put a 2 out here so I don't forget to multiply. So now in here I can combine like terms. -14 plus 1 is -13. So I'm going to do 2x squared minus 13x minus 7. So now I'm ready to multiply by 2, so I distribute this to everything. So 2 times 2x squared, 4x squared. 2 times -13x is -26x. And 2 times -7 is -14. Because this is a positive 2, it does not change the signs. It still stays the same. Positive, negative, and negative. Okay? All right. Awesome. I hope you got that. Let's go ahead and keep going. So sometimes when we're working with quadratics and foiling, we have something called a special situation like a difference of square. A difference of square is something like x plus 4, x minus 4. So if you notice, we have the same variable first, the same number second, and it's a plus and a minus, okay? So they're different signs. When we FOIL this, we can look at how it FOILs. I'm going to FOIL it normal. X times x is x squared. Positive 4, outer. X times negative 4 is negative 4x. Inner, positive 4 times x is positive 4x. And last, positive 4 times negative 4 is negative 16. What happens here is that negative 4 plus 4 actually cancels out, and the answer becomes x squared minus 16. So sometimes people like to memorize x plus 4, x minus 4 gives me the square of the first one minus the square of the second one. Okay? So that's just something to kind of keep in mind. So before we move on, let's look at another example of that. So x plus 2, x minus 2, I see that it has the same first variable, the same number, and the signs are different. Okay, so this is difference of squares. So x squared minus 4. I square the first one minus I square the second one, and that gives me the answer. Okay? Let's look at one more example, and I want you to give it a try. Okay, so you can hit pause now, and you can give it a try. When you're ready, just hit play, and I'll go over it with you. Okay, here we go. So this one would be the square of the first one minus the square of the second one. Now, I will say this. I'm just showing this to you because sometimes it could come up as a question. But if you prefer to FOIL it out completely and just take that extra step to make sure you get it right, that is completely okay. And it's actually encouraged. But if you ever see something that says difference of squares, then now you know what it means. And that's what matters. Okay? All right. So let's look at the next step in this, which is factoring quadratics. So quadratic equations, remember, are ones that have this right here, our famous square on the variable. And there's nothing higher than that as an exponent. The square is the highest exponent. Okay, so let's say it's like 2x plus 2. Okay, now the same way that something multiplies to become this, the way we did here, sorry, I'm going to take you back real quick, with the foiling, we can go backwards. We can go the other way to go from this to something with parentheses. Okay? So let's say in this one, this would be x plus 1, x plus 1. Or x plus 1 squared. Okay? Now, how do we do that? How do we know that? Well, that's what I'm going to show you now. Step number 1, you want to, so I'm going to put this in steps for you, okay? Step number 1, you want to list the factors for the third component of your quadratic, okay? So list the factors. Remember, the factors are the numbers that multiply to equal that number. Okay, they multiply and the product will be the third number. The second step would be to choose the factors that add or subtract to equal the second number. Okay, which would be this one right here. For example, the factors of 1 are 1 times 1. Okay, but we also have to think of negatives. Negative 1 times negative 1. gives me positive 1, right? So which one of these adds up to 2? I need it to add up to 2. So 1 plus 1 gives me 2. Perfect. Negative 1 minus 1 gives me negative 2. That's not what I'm looking for. So this is what I use. And then I assemble it into my parentheses. Okay, so that might be a little confusing the way I explained it, but I hope now that when we do some practice, it'll kind of come together for you a little bit better. Okay, so first one, factors of 56. Okay, let's see. 56, 7 times 8 equals 56, and 4 times 14 equals 56, and 2 times 28 equals 56. And it's positive. I could do negative 7 times negative 8, negative 4 times negative 14, and negative 2 times negative 28. Remember that a negative times a negative equals a positive. So that's why I can consider those. Now I'm looking for something that was step 1. Step 2 is I'm looking for something that adds up to give me positive 15. So immediately I can eliminate these negatives because they're going to give me a negative. So here we go. 7 plus 8 gives me positive 15. So we found our winner. 4 plus 14 gives me 24. Sorry, not 24, 28. And 2 plus 28 gives me 30. So I'm going to set up my equation now. X plus 7. I use the first one. And the second one is going to be x plus 8. And that's it. Okay? Let's go ahead and try another example. So this one has negatives, so it's going to be a little more complicated. Let's find the factors. 12 is 1 times 12, 2 times 6, 3 times 4. But this is negative. How do we multiply to get a negative? A negative times a positive gives me a negative. So I'm going to do negative 1 times positive 12 and positive 1 times negative 12. Negative 2 times positive 6 and 2 times negative 6. Negative 3 times positive 4 and 3 times negative 4. Okay? All of these scenarios will give me negative 12. So now I have to find which one adds up to give me negative 1. So negative 1 plus 12 gives me positive 11. That's no good. 1 plus negative 12 gives me negative 11. That's no good. Negative 2 plus 6 gives me positive 4. That's no good. 2 minus 6 gives me negative 4. That's no good. Negative 3 plus 4 gives me positive 1. That's no good. And 3 minus 4 gives me negative 1. That's exactly what I'm looking for. So now I'm going to set up my parentheses. And I'm going to fill it in with these two. Positive 3, negative 4. And that is my answer. Okay? All right. So now that we've gone over 2 of them, I want you to give it a try on your own. So I encourage you to pause the video at this point. Give this one a try and get as far as you can. Even if you can't get all the way to the answer, that is okay. Just get as far as you can. And when you're ready, just hit play again to watch the explanation. So with this one, we're going to do our first step. We're going to find the factors of 18. 1 times 18, this is positive, so it could be negative 1, negative 18 also. 2 times 9, or negative 2 times negative 9. 3 times 6, or negative 3 times negative 6. And that's it. We can't do 4. Okay, so now we want it to add up to negative 11. So let's go ahead and see which one does. 1 plus 18, 19. Negative 1 minus negative 18, negative 19. 2 plus 9, positive 11. Negative 2 minus 9, negative 11. And there it is. So now I set up my 2 parentheses, x and x, and I'm going to put these in here, x minus 2 and x minus 9. Okay? I hope you got it. All right. So let's do another example. go ahead and hit pause. Give this one a try. When you're ready, just come back and I'll go over it with you. Okay, here we go. So let's look at the factors of 21. And this is a negative 21. So we have negative 1 times positive 21, or positive 1 times negative 21. Negative 3 times positive 7, or positive 3 times negative 7. And that's basically it, right? There's not much that multiplies to equal 21. Okay, so now let's figure out which one gives me positive 4, because that's what we want. We want it to add up to positive 4. So negative 1 plus 21, that's not going to work. And 1 minus 21 is also not going to work. That gives me positive 20 and negative 20. So negative 3 plus 7 gives me positive 4. That's what I'm looking for. 3 minus 7 gives me negative 4. That's not what I'm looking for. So I set up my two parentheses and I fill in the information. Minus 3 plus 7. And that's it. I'm done. Okay, here we go with another example. Go ahead and give this one a try. Just hit pause. When you're ready, just come back and watch the explanation. Alrighty, so this one's pretty easy. It's all positive. So 36, we have a lot of factors to work with. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. All right, so 1 plus 36 gives me 37. 2 plus 18 gives me 20. 3 plus 12 gives me 15. There it is. So we do x and x plus 3 plus 12. And there we go. Okay, I hope you got that one. All right, guys. So that's basically it for the more challenging aspects of the algebra questions you might come across in the mathematics knowledge. You're going to get some more challenging questions in later modules, but for the time being, this is the next step. Please make sure that you give that test underneath this video a try, and if you miss any of the questions, just go over it, and feel free to post a comment if you have any question at all.